Hello, in this second lesson on our chemical analysis topic, we're going to continue looking at positive ions and we're going to look at something called a precipitation test. Before we get into that, I want you to just remind yourself about the tests we have met so far. So you should have a stack of key cards, hopefully safely in the back of your planner. We want to take those out, sort them through so that the name of the substance is facing up. I then want you to take the top card, read the name aloud, and then I want you to say out loud the test and result. Flip the card over, check if you're right. If you get it right, brilliant, put it down onto one side. If you get it wrong, put it to the back of the pile. I want you to then go through that until you've made all of your cards into the correct pile. It's really important that this is something you build into your week. So try and put these cards somewhere, come back to them regularly and test yourself. So pause here and do that, please. Right, so we're now going to think about our positive ions, but what you do if you do a flame test with something you know has a positive metal ion, but the flame doesn't change colour. So not everything will change colour, but those substances will form compounds that have a distinctive colour. So we're thinking now about doing a chemical reaction to make a compound and then using the colour of the compound to work out what that ion might be. So first up, this word precipitation. In a precipitation reaction, we take two soluble substances and mix them together and they make something that is insoluble, a solid, okay? And that's called a precipitation. So this we've looked at before. This is where we get our lead nitrate and our potassium iodide, two soluble salts, mix them together, and the resulting substance you can see is the beautiful solid yellow substance, our lead iodide. Okay, so that's a precipitation reaction. The solid we make is called our precipitate. Right, so the theory is that we take the thing that we don't know about and we mix it with some sodium hydroxide. When we do that, our positive ions will swap places. So our sodium ion will join onto the non-metal thing, and our metal ion that we're trying to identify will join onto the hydroxide and make a metal hydroxide. That metal hydroxide is solid, that's our precipitate, and it will be a distinctive colour. And the colour that it turns is the colour that it tells us what our metal is. Okay, it's distinctive. So, again, I can't be in the lab, sadly, to show you these. So we're going to watch this video. It's produced by Primrose Kitten, which goes through how we do those tests in the lab.
So we're going to be looking at a test on positive ions with calcium, iron 2, iron 3, aluminium, magnesium, and ammonium, and you react them all with sodium hydroxide. So starting with calcium, I'm doing this in a test tube, but when I get my students to do it, they do it on a these laminated cards so they can see the colour change. So I'm adding sodium hydroxide, and what we can see forming is a white precipitate. So you need to know calcium, when mixed with sodium hydroxide, forms a white precipitate. The next one I'm going to do is going to be copper. So taking a nice lot of my copper into my test tube, reacting that with my sodium hydroxide. And if you watch what happens, you can see, let me bring that up a bit closer for you. You can see that a blue precipitate has formed on that. Try and get that to focus. Okay, so there's a blue precipitate up top here, and the unreacted copper is down there. If I just give that a bit of a shake, you can see it is all turning into sludgy copper precipitate. So the next reaction is iron 2. So squirting my iron 2 in here and adding my sodium hydroxide. You can see that we have a brown precipitate being formed. And again, if you look really closely around the edges, you can see some of the unreacted iron 2 solution. After iron 2, I'm going to use iron 3. Oops, it's a bit stiff to get out. There we go. So iron 3 solution starts off looking very similar and a very touch confusing with iron 2 and iron 3. This is something we go into a lot more at A level. So the iron 3 has formed a kind of like a more rusty browny colour, whereas this colour here is more of a greeny browny colour for iron 2. Then we have our aluminium. Just get the lid up on this. Put my aluminium in there. Now this does two things. You can see it goes white at first. So that's our white precipitate from aluminium. And then if I keep adding the sulfuric acid, you can see, especially down the bottom here, it's starting to go clear again. So aluminium, it goes white at first, and then when you add excess sodium hydroxide, you can see that the white is starting to disappear and it is going clear again. Then we have magnesium. So put my magnesium in there, adding in my sodium hydroxide, and this again has formed a white precipitate. And just because it's here, let's have a go at, can't get this out. Let me just cheat slightly and pour it. Okay, so ammonia, add some sodium hydroxide, and nothing happens. So if I just bring it down here, we can see that calcium forms a white precipitate, copper forms a blue precipitate, iron 2 forms kind of a browny greeny precipitate, iron 3 is more browny red precipitate, aluminium forms a precipitate that starts white, and then as we add more and more, it goes back to clear. And then magnesium has a white precipitate at the bottom, and nothing happens with ammonia. So we can.
Okay, so here's a summary of the method for that. She made a slight error in the video and mentioned sulfuric acid. You don't need any sulfuric acid. She just said the wrong word there. So precipitation test is ultimately very straightforward. You take a test tube, you put in the thing you're trying to identify, you add some sodium hydroxide, you write down anything that happens, you add a little bit of excess sodium hydroxide, and then see if anything happens. Okay. So summary of the results. So there were a couple there that went white. If you added sodium hydroxide to magnesium, it went white. Aluminium, it would went white. And also if you added it to calcium, which we looked at with the flame test, it would also go white. You could determine if you had calcium because you could do the flame test. But if you've got two things that are white, you need to add excess sodium hydroxide to work out which is magnesium and which is aluminium. So if you add excess and it stays white, it's magnesium. If you add excess and the white goes away, then you know you've got aluminium. The other ones we saw were quite distinctive colour changes. So we saw copper. If you've got copper 2 ions, you'll get a blue solution. If you've got iron 2, you will get a kind of a browny green colour. And if you've got iron 3, you'll get that orangey brown colour. So what you now, to get your last set of key cards, you need to make them for magnesium, aluminium, iron 2 and iron 3. And then you need to add the detail onto your copper and calcium cards about what would happen if you did the precipitation test. So pause the video here, please, and complete your key cards. Right, bit of a brain puzzle for you. Here is our statement. When sodium hydroxide solution was added to a solution of the compound, a white precipitate was formed. On adding excess sodium hydroxide solution, the precipitate was insoluble. When the solution was tested in a flame, the colour was orange-red. What am I? So dig out your key cards, pause the video and have a think. What positive metal ion is in this solution? Okay, let's work through the puzzle then. So we've done a precipitation test. We've added sodium hydroxide solution and we've got a white precipitate. So we could have at this point, it could be calcium, or it could be magnesium, or it could be aluminium. We've added excess sodium hydroxide solution and the precipitate is insoluble. So we know it can't be aluminium, so we're down to calcium or magnesium now. We flame tested the solution and the colour's gone orange red. Well, magnesium doesn't react in a flame test, so it can't be magnesium. We know that calcium produces that orange red colour, so our unknown is calcium. Hopefully you got that one right. Right. Next little bit then is thinking about equations. Now, this is a really high level application of all the chemistry we've met so far in this context of ion testing. The syllabus simply states students should be able to write balanced equations for the reactions to produce insoluble hydroxides. So that means for the reactions that we looked at that made those precipitates, you should be able to write an equation. Problem is that there are lots of different things that could be your non-metal. So it's not as simple as just learning a load of equations. This is really application. However, there's two things you do know. Since during our reaction, our sodium and our metal ions swap places, we know that one thing we make would always be a metal hydroxide because the metal ion will join to the hydroxide bit. So these two will swap and you will always make a metal hydroxide. We know that the sodium ion in the sodium hydroxide will always swap places and join to the non-metal. So therefore, one thing you will make would always be a sodium compound. So you know that, you just need to figure out exactly what they will be. And that's our real high level application. It can be quite helpful to think about this in terms of ionic equations. So thinking first of all, our metal ion is positive, our hydroxide ion is negative, and so our metal hydroxide ends up being neutral. So in general, any metal positive ion will join with our OH minus to make something hydroxide. Now this formula will depend on what the positive charge is. If it's a +1, it's a 1-to-1 ratio. If it's a +2, then you'll obviously need 2 of these and so on. Similarly, our sodium is a +1 ion and it will join to our negative non-metal to make an overall neutral compound. So again, Na plus and our unknown minus will make our compound, but it might not be a 1-to-1 ratio if your negative bit doesn't have a -1 charge. Again, this comes back to knowing this table. If you know this and the ion charges, you can figure it all out. So to write our balanced equation, there's several steps we need to go through. And I'm going to give you an example looking at this. So if I had some magnesium nitrate, so the magnesium is my metal that I'm trying to figure out, and I've got sodium hydroxide, I'm going to make magnesium hydroxide and sodium nitrate. Okay, and I want you to try and write a balanced equation. So first step is to figure out the charges of your ions, to use the charges to work out the formula of the compound, to write the substances out in an equation, and to balance that equation. If you feel you can, pause here and have a go. If you don't even know where to start, then keep the video playing and I'll talk you through it. Right, first up then, I need to identify what ions I've got. So I've read the words, I've got magnesium nitrate plus sodium hydroxide. So my ions are magnesium, nitrate, sodium and hydroxide. I've used that little table that we've got to work out the charges on the ions. I'm then going to use those charges to figure out the formula of the compound. So magnesium nitrate is going to have magnesium and nitrate. Magnesium is 2+, nitrate is -1. So in order to end up being neutral, I need 2 lots of this nitrate, 2 lots of NO3 minus to balance it out. So my formula is MgNO3 2. That's my formula. So if you look through the table, you can see there, I've followed that through and worked out all the formula of the ions. Step 3 is then to write that into an equation. So my magnesium nitrate is here, plus my sodium hydroxide gives me magnesium hydroxide and sodium nitrate. Finally, I need to look at all of my different atoms and count them up to balance the equation. And that goes in as big numbers at the front. So I put in my multipliers, I need a 2 on my sodium hydroxide and a 2 on my sodium nitrate. If you're still struggling with balanced equations, there's loads of resources out there. I've posted them before. Go back to those and practice this. Okay, I want you now to apply that to the ions that we are working with. So I've put here all the different ions that we test for, and I've written here the ionic equation for testing. So the magnesium ion will always join on to the hydroxide ion to make magnesium hydroxide. So I've helped you out a bit by giving you this section here. There are lots of things that magnesium could be joined onto. So I've just made some up, some possible things it could be, but this isn't, you could have magnesium sulfate, you could have magnesium chloride, magnesium iodide, all kinds of stuff. I've just picked some. So next to each of them, I have written a possible word equation of something that could happen. I want you to fill in these boxes here. So at the end, I want you to write a symbol equation for that word equation. So magnesium sulfate plus sodium hydroxide makes magnesium hydroxide and sodium sulfate. You need to use the table, use the steps, and fill in the equations. Pause here and do that, please. Right, I want to see how you get on with those equations. So I'm not going to give the answers at the moment. I want you to send me a photo of your work. If that's filled up your lesson time, then stop here and send me some photos of the work you've done in the lesson. If you've got a little bit of time, I want you to have a go at this exam question. So there's part A here and then a bit on the next page. So pause here and do this question. Okay, now play on to the next little bit and have a go at this. You can see we're linking together different topics. We've got our nano from our structures and bonding topic. We've got some bits on water where we're thinking on our using resources topic. So pause here and finish the exam question, please. Okay, here's the mark scheme. So mark your work and give yourself a score out of 6. Right, can you now then take a photo of your key cards, photo of all the equations you've written, and if you had time to do so, mark your marked exam question. Upload that onto the Google Classroom. Thank you.